What is switchgrass? Switchgrass, or its specific name is Panicum virgatum, is mainly lived for its heavy growth during late spring and early summer. It is easy to identify them because they have white patch of hair where the leaf is attached to the stem. Based on its characteristics such as shallow and droughty, switchgrass is climatically adapted throughout in the most of United States. Do you wondering what are the uses of switchgrass? Firstly, it provides a good warm season and high quality hay for livestock. Besides, switchgrass acts as stabilization plant on critical areas and suitable for low windbreak plantings. Last but not least, switchgrass is used as biofuel for electricity of cellulosic ethanol production. Next, I will explain about the process description. Firstly, chopped switchgrass is fed into storage hopper. Secondly, from hopper, the air in the blower is used to transport the switchgrass by using pneumatic system. Pneumatic transport is used to convey the switchgrass through the pipeline that connected between the storage hopper and the fluidized bed dryer. The switchgrass is sent to fluidized bed dryer to dry the particles before processing it into biomass product. Hopper is a container for a bulk material to be stored and transferred in or out of the container. Hopper is used in industry for protection and storage of powdered materials. It must be designed such that they are easy to load and unload. Powder flow behavior in the bin and hopper is controlled by the shear properties of the powder wall friction and compressibility. Amount of volume and mass will determine how much bulk materials can flow in certain times. Now, let's proceed to the next part on how mass flow occur in the hopper. Firstly, bulk of switchgrass will flow into the hopper. In a mass flow hopper, all the material inside the hopper move down the walls. The material in the center falls through the outlet, creating a channel. Switchgrass particles will exit and flow through the pneumatic pipe for the next stage in the fluidized bed. All the properties and values such as compacting stress, unconfined yield stress, bulk density, shear stress at the wall, normal stress at the wall, and effective angle of internal friction that we use to calculate the minimum outlet dimension are from references. After calculating, the value of phi, ff, and theta are 14 degree, 1.52, and 32 degree respectively. In order to design the hopper, firstly, we need to get the value of minimum outlet dimension, which is 0.27 meter. For a bulk material to flow, friction must be overcome. Hence, the rougher the wall surface, the larger the friction angle. After that, we design the hopper by assuming the dimensions such as cylinder diameter, cylinder height, and cone height that's suitable with our production rate. The volume of cylinder and cone are 10.996 meter cube and 1.81 meter cube respectively. Last but not least, the mass of particles are 10312.05 kilogram. For the next system, the switchgrass is transferred from the hopper to the fluidized bed dryer through an enclosed pipeline called pneumatic transport system. With the help of the air mover, which is blower as the motif of air source, a combination of pressure differential and the flow of a gas provide force to move the switchgrass to the next system. As the switchgrass from the hopper is originally fairly dry, this system is suited for the particle transfer. For further explanation, let's look to the pipeline design parameter. The pipe has an inside diameter of 0.2 meter, whereas the length of vertical pipeline is 5 meter and for horizontal pipeline is 10 meter. The viscosity and density of ambient air at 25 degrees Celsius are 18.6 times 10 to the power of negative 6 Pascal second and 1.2 kg per meter cube. In this system, the air pressure in the conveying line is changed by the system's air blower, which generates the pressure. The blower pushes the air through the system and the system runs under pressure. As the energy is required to move the switchgrass through the pneumatic conveying system, the pressure differential acts as the energy supplier in this case. This design was evaluated by the calculation of pressure drop of horizontal pipeline, pressure drop of vertical pipeline, and pressure drop of the bands. The pressure drop across the length of the transport line consists of 6 components, which are pressure drop due to gas acceleration, pressure drop due to particle acceleration, pressure drop due to gas to pipe friction, pressure drop related to solid to pipe friction, pressure drop due to the static head of the solids, and pressure drop due to the static head of the gas. For the horizontal sections calculation, the terms 5 and 6 are become 0 as the theta is equal to 0 for horizontal pipeline. Thus, the pressure drop of horizontal pipeline is 917.10 Pascal. Next, for the vertical sections calculation, the terms 1 and 2 become 0 as the initial acceleration of solids and gas were assumed to take place in horizontal sections. Thus, the pressure drop of vertical pipeline is 365.2 Pascal. For the bands calculation, since there are only 2 bands with 90 degree were assumed, the pressure drop is 1095.6 Pascal. Thus, the total pressure drop of the system is 2.38 kilopascal. What is fluidized bed? Fluidized bed is a bed of small solid particles suspended and kept in motion by upward flow of a fluid. Basically, fluidized bed involves drying, mixing, granulation, and coating of particulate materials. Fluidized bed drying is commonly used technique for drying pharmaceutical powders, granules, and slurries. Next, let's proceed to process of fluid bed drying of switchgrass. Firstly, the chopped switchgrass from hopper section is delivered into top inlet of dryer by pneumatic transport. Secondly, vibrations convey the chopped switchgrass through drying sections where air is in a gradually decreasing temperature of particle. Thirdly, water from chopped switchgrass will be evaporated during this stage where the required dryness is obtained through fluid bed casing. Lastly, any larger particles at outlet of the dry bed are screened and recirculated to inlet. The design of fluidized bed dryer are as shown below. The dryer has a diameter of 2 meter, whereas the bed height is 5 meter. Table below shows physical and flow properties of commercial switchgrass after undergoes drying process. Hot air medium is used during this spray drying. Temperature range is from 100 to 150 degrees Celsius, and the assumption of the initial hot air temperature is 105 degrees Celsius. The design of dryer was verified by the calculation of pressure drop across the bed when it becomes fluidized. Firstly, we need to find the minimum fluidization velocity UMF by determining the Archimedes number. From the value of Archimedes number, we get value of UMF is 1.6253 meter per second. Since the particle size is 7.81 times 10 to the power of negative 3 meter, Vt can be determined by using the following formula. From the equation, we get terminal velocity equals to 2.4668 meter per second. After that, from the parameter design of fluidized bed dryer, we get volume of bed is equal to 15.7 meter cube. The next step is to determine voidage of packed bed, which is 0.278. Lastly, by using the force balance equation, the value of bed pressure drop when fluidized can be determined. Thus, pressure drop of the system is 39.444 kilopascal. As a conclusion, we have achieved the objectives, which are to propose hopper, pneumatic transport, and fluidized bed dryer design. The overall process of our design for switchgrass is firstly, the bulk material is stored in hopper and then it is transferred to fluidized bed for drying through pneumatic transport.